Good. Welcome to this week's course. Today you will learn about Python 3, and I will give you an introduction hopefully from scratch. So if you have never heard of Python before, hopefully by the end of today you will be able to write your first Python program. And maybe even if you have heard about Python before, you might learn something new anyway. So in particular, you will learn how to run a Python script. I will tell you where you can get more information about Python in general. You will learn about variables and types. I will tell you about control structures. So these are if, for loops, and while loops. I will tell you how to write functions in Python. I will tell you how to document your code, something that is very important if you share your scripts. I will tell you how to read and write files in Python, and then finally how to use modules. So this is also, modules are also a concept for organizing your scripts in a more logical order and also sharing your work. But first of all, most importantly, what happens if you're lost and you need to get help in Python? There are various different ways for getting help. Here are some good books and tutorials that I can recommend. So these are links. If you open up the IPython notebook, you can click on these and it will bring you to the web page. So there's the official Python library reference and the official Python 3 tutorial. These are maintained by the Python developers, and they give you a really nice overview over the Python language and all the different types it comes with and all the different features that it has. There's also a book called Think Python. It's a book that you can download as a PDF or buy. That also gives you a nice overview over the Python language. And then finally, there's a nice Python introduction via an example from bioinformatics by Hans-Peter Langtangen and Sandve. So this example is based on Python 2, but you will see actually the differences between Python 2 and Python 3 are fairly minimal. So you can also do this example if you like and just adapt Python 2 to Python 3. Also, Python comes with built-in documentation. So if you want to know something about a specific module that you're working with, or maybe a function in a module that you want to learn more about, you can use the command pydoc in the bash shell. So just type in pydoc and then the name of the module, or pydoc module name.function name, and it will give you the documentation about that function. So here's an example where I typed in, I hope you can read this on the back, I typed in pydoc io.open, and you can neglect the exclamation mark on the font. But if I type this in, then I get everything about this function, and I can actually scroll through it and read loads about all the different arguments that this function has and so on. So this is a really nice way of getting help about a specific function that you want to use. Okay, with that, let's look at our first Python program. And the first Python program that we're going to look at is a Hello World program, of course. Here it is. So this is our script that we're looking at. It's only 5 lines of code. Here the last line should not be wrapped. It comes to the end. And so we can save this script as a file hw.py. And you can see it's fairly easy to read. We can already, just by looking at it, we can probably guess that we are printing out something like hello world, and then sinus of something equals something else. So even without knowing too much about Python, we can maybe guess what might be happening in this program. But before we can run the script, we need to install Python first. There are different ways. I recommend installing Python through the Anaconda distribution. So again, this is a link that you can use, or just Google Anaconda. And it works on all most operating systems. So you can install Anaconda both on Mac, Windows, and Linux. And once you have installed it, you should have this Python command in your available in your bash shell. And if you type in Python ---- version, then you get the version of Python that you're using. And so in this course, we're using Python 3. So everything, ideally, you should have Python version 3.5, but anything larger or equal to 3 will be fine for this course. If you see Python 2 here, then you need to make sure that you installed the right Anaconda distribution here. Okay? So for example, Mac OS X comes with a default Python, but this is Python 2. So in case you have a Mac, you will need to install the Anaconda distribution to update your Python. So now we have installed Python. We have saved our script in the file hw.py, and then we can call it. So we just type in the command shell Python hw.py, and then here we also provide a command line argument, and we see what the program does. It writes out hello world, sinus of 0.8 equals 0.7173, and so on. So this always works by typing in Python and then script name. Alternatively, if you're on Linux or Mac OS X, you can make the script file executable by typing in changemod a+x hw.py. So this changemod changes the permissions of a file. And with this a+x, we make the script executable. And once we have executed this command, then we don't need to type in the Python here anymore. We can directly in the bash, we can just type in ./hw.py with the argument here, and we get the same answer. So these are just two ways how we can run Python script. So now let's look at a bit more detail on what happens in our script. So the first line that we had was this magic command line that we've already seen from bash programs. So here we have this hash exclamation mark user bin env Python. And this tells our operating system which type of script it is and which interpreter it should call. And so in particular, we tell our operating system that this is a Python script and it should be executed with a Python interpreter. In Python, actually, all comments start with a hash. So the Python interpreter itself will just ignore this line because it's for Python, this is just a normal comment. The next two lines read from math import sign and import sys. And this is a way in Python how we can access additional library information, or what we will also learn later on as modules. And so in other words, here we import the library functionality sign to compute the sinus of a number. And also we import this module sys that allows us to access command line arguments. So after these two lines, we have access to the sinus function and the sys function. Okay, in the next line, we extract the first command line argument, and we use the sys.argv list here to access that. So sys.argv gives us a list of all the command line arguments that the user has specified, and we take the first command line argument and convert it into a float and store it as a variable x here. And finally, we print out the result. So our print statement is very familiar if you're used to C or also in bash. So here we just, the print function, and as an argument it takes in a string, and we can pass in parameters or variables into that string. So here we pass in x as the first parameter, and then sign of x as the second parameter. And if we want to control how exactly these numbers should be printed out, we can also specify that in these curly brackets, in these placeholder brackets, using the printf syntax. So here, for example, with this .3f, we tell Python to print the 3 significant digits of a number. And so you have a lot of flexibility on how you want to print out, to screen. So I've told you that you can run Python programs with Python and then the script name, but you can also just type in Python to your command shell, and that will give you an interactive Python shell, which means that you can actually type in Python commands, hit return, and then it will run it. And you can type in the next command and run it again. So this is an interactive shell that is often quite useful if you want to just play around with a little problem or understand how maybe function assignment works and so on. An even better alternative to Python is IPython, which is also an interactive Python shell, but it has additional functionality. So you just type in IPython, and so, for example, you can, in the IPython shell, you can actually run Python scripts by typing in run hw.py and then a command line argument if you want to. IPython also supports a lot of other things like tab completion, additional help commands, and much more. You can also launch a Python script anywhere in your program. So maybe you have a long script, and somewhere in the middle, somewhere in the middle of the script, there's a bug, and you want to inspect what the bug is. So in this case, you can just add to your script from IPython import embed, and then call this embed function. And what that will do is when it hits this line, it will stop the program and jump into an interactive Python shell. And at this point, you have access to all the variables that have been defined, and you can print them out, you can change them, you can call functions, and so on. So it's a very good way to just stop your program at a specific point and inspect all the variables to see where maybe the problem is. Even for more advanced users, it's useful to know that Python also comes with an integrated debugger. You can launch this with the IPython --PDB. And so a debugger allows you to not only inspect the program at one point, but also to step forward line by line through the program and always check what the status of the program is. So I wouldn't recommend this to start with debugging with a debugger straight away, but if you have very complex problems and you're hitting a complicated issue, then it might be worth to launch a debugger. But so from my experience, in most cases, it is actually sufficient to just add this line from IPython import embed to the point where maybe one line above. So you run the script, it crashes somewhere, and typically what I do is I just add this line, one line above the point where it crashed. And so then I can, for example, repeat the line that caused the crash, or I can inspect maybe there's some kind of none pointer instead of a valid object, and so on. Okay, let's talk about, so I gave you an example of a simple Python script, but let's look a little bit more deeper about the types of variables and data types that Python comes with. So generally in Python, variables are not declared. So we don't have to specify, or we don't have to specify the type of a variable before we start using it. We can just write x equals 5, and after that line, we will have x will be a valid variable. The second important thing to note is that variables always hold reference to objects. So for example, here, if I write a equals 3 in my script, a will be a reference to an integer object which contains 3. If I type a equals 3.0, then a will be a reference to a floating point object that contains the number 3.0. Or here, I have a equals colon 3 dot colon, and these colons are used in Python to mark strings. And so in this case, A will be a reference to a string object contain 3, and so on and so forth. So here in the last line, I make a list, a reference to a list that contains the string 1 and an integer 2. So it's also important to notice that Python is strongly typed. So every variable in Python has a specific, is an object of a specific type. And we can check which type it is by using the isInstance function. So in this line up here, in this line here, we check if isInstance A is int. So we check if the A variable is of type integer. And if it is, then we execute these statements below that line. The second if statement checks if A is of type list or of type tuple. So we can actually check if an object is of one of the following types. And again, if this is the case, then we will execute a block of statements. So here are some common types in Python. If you want to store numbers, then you typically use int objects, floating points, or complex types for storing complex numbers. Python also comes with sequences. So a sequence is, it's a list of things. So for example, strings in Python is just a sequence of characters. You can also have the list type allows you to store a list of other objects. So you can have a list of integers, or you can have a list of floats, or you can also mix them, the types in a list. You can have tuples and ND arrays. You also have mappings. So mappings, the main mapping that is being used in Python is the dictionary, dict. And in other programming languages, you might know this as hashes. So these are basically key value storage objects. And then finally, you can even define your own types, user-defined types, using the type. So here are some simple assignments that you do in Python. In the first one, you just create a new variable A and make it a reference to a number 10. In the second line, you create a new variable B and let it point to a Boolean variable, the Boolean variable true. And so now in the third line, you change the variable A so that it points to the Boolean value that B points to. So now both A and B both point to the Boolean value true. In the next line down here, we call a function increment 4, and we make B reference to the result that increment, to the return value that increment gives us. So we call a function, it gives us it gives back a value, and that's what B now points to. And in the last line, we have an expression on the right-hand side. We check if A is equal to B, and if this evaluates to true, then is equal is going to be true. And if this expression evaluates to false, then is equal will be false. So here a list on, so I talked about different types. So the most very important types in Python are lists and tuples. Here's an example of lists. So a list is simply a list of different objects in Python. So the first list up here is I create a new list using square brackets. So I open and close with square brackets, and then I provide a list of objects separated by commas. And my first item in the list is a string, the second item is a float, the third item is an integer, and the fourth item is again a string. So you can mix different types in the list. You can also change existing objects. So here what I do is I take the second item in my list. So in Python, the indexing always starts at 0. So if I type in my list bracket 1, I get the first item of the list, and I replace it with the value -10. So after this operation, I will have a list saying a string, -10, 6, another string. And I can also use this function append to append something to the list. So after calling this here, this line here, I will actually have a list with 5 items, and the last item will be a third string. Tuples work very similar, except that they're constant, and which means that you can't change them once you have created them. And this is also called immutable. So immutable meaning that once you have created the object, it's constant, you can't change it. And this is in contrast to mutable objects, where you can change the content. So the list is an example of a mutable object. We were able to change it. So down here you have some examples for how you create a tuple. You create a tuple by using normal brackets rather than the square brackets for lists. An alternative syntax is you can just leave out the curly brackets and just provide a list comma separated sequence on the right-hand side. So this is automatically, Python will make a tuple out of this. Now, if you try to change one of the values in your tuple, for example, providing my tuple, the second object equals -10, you will get a runtime error saying my tuple is an immutable object, you cannot change it. So here's a list of functionalities that is often used when you work with lists. The top one creates an empty list. So here I just write a equals square brackets open, square brackets closed. The second is initializing a list as we've seen it before. Then we have the append function for appending something to a list. We can also concatenate two lists with a plus object. So if you have one list plus a second list, gives you a new list that has the length of both combined together. We can call the insert statement to insert an element at a certain index. We can use the index notation here to get an element at a certain index. If we use a negative index, then we work from typically with a positive index, if you use index 0, then you get the first element. If you use the index -1, you get the last element. If you use the index -2, you get the second last item in the list, and so on. So with negative indices, you can actually work your way through the list from the right-hand side, while with positive indices, you can access items in the list from the left-hand side. You can also slice your list, slicing meaning that you get a sublist starting at a certain index and stopping at a certain index. So here use this square brackets 1:3 to get a sublist with the indices 1 and 2. So you can extract sublists. You can remove elements. You can remove elements from a list with del A equal del A3. So this will remove the fourth item in the list. But you can also call the a.remove method to remove a certain object from the list. So with del, I specify the index that I want to remove, and with a.remove, I specify the object that I want to have removed from the list. And in fact, this removes all elements of the list that takes the value e. So if I type in a.remove 1, it will remove all the ones that I have in my list. You can find the index of an element in the list. You can check if a value isn't in a list. You can check how often a value shows up in a list. You can check how long the list is. You can check the minimum value, the maximum value. You can sum up a list. You can sort a list. You can reverse sort a list. And you can also use nested indexing. So you can make lists of lists. And in such cases, you need to use this nested list indexing to get the underlying elements. And of course, you can check if an object is of type list using the isInstance method. Or alternatively, you can type in type of I. This returns the type of the object, and check if this is indeed a list. The same thing works for tuples. I won't go through it in detail here, but it's basically exactly the same thing, except that you can't do anything that would change the tuple, right? So here you don't have a.remove, you don't have a.append, and so on. But otherwise, basically, all the operations that work with lists also work with tuples. Another very important type in Python is dictionaries. And a dictionary is basically a key-value pair. And the keys that you use in dictionaries have to be immutable, so constants. So just to give you an example, a list is a dictionary, basically a list is a dictionary where the keys are integers. Okay, so a list is something where I can give an index and I give the index as an integer, and then I get a value back. A dictionary is a generalization of that. So rather than using integers, I can use any type of immutable object as a key. And so here's an example. Here on this first line, I create a dictionary. Dictionaries are created with the curly brackets in Python. And the way you create this is you always specify a key, colon, and then the value. So here I create a dictionary with one key-value pair, a second key-value pair, and a third key-value pair. And the keys here is first an integer for the first two items, and it's a string for the last item. So strings in Python are also immutable objects, so I can use them as a key. An alternative way of creating dictionaries is using the dict command. And so the dict function takes an arbitrary number of arguments, and you always provide the key as the name, the keyword argument, and then the value, what you want the value for this key to be. So here we create a dictionary with name equals John D and phone equals this number here. So after we've created it, we can ask for certain items in the dictionary by using the same notation as we used for lists. But now, rather than just putting in numbers here, I can actually use any type of key here. So in this case, actually I create a new key-value pair. I add a new key-value pair to my dictionary. So here I say I also want some key. I want some key to be to take the value 1.0. I can also update my dictionary using the update method, which takes another dictionary and it merges the two dictionaries. So after this operation, you also have all the key-value pairs in other dicts also in my dict. And once you're done, you can also remove items from your dictionary by using the index notation, just like for lists. You can type in del mydict2 to remove this object here, 2, 3. So you remove the item with the key 2. And you can also remove the item with the key some key. So after this operation, you will remove this key value pair here. So dictionaries, again, is just a generalization of lists where you can use also non-integers as indices. So here's the functionalities that you have for dictionaries. It's pretty much the same as we had for lists and tuples, except that you now use curly brackets, and you always have to provide a key-value pair in the initialization. And then we have these update statements here, where we can merge two dictionaries. And maybe something to point, the rest works pretty much the same. Something that is quite useful if you want to loop through all the keys in a list, you can use the for key in A, where A is in a list command. You can also get a list of keys by typing in a.keys brackets. So this will return a list with all the keys that you have in your dictionary. You can also get a list of all the values by typing in a.values. So again, this will give you a list with all the values in a dictionary. Okay, so we learned about lists, tuples, and dictionaries. The next thing to talk about is strings. So strings in Python are created with single semicolon or double semicolons. Or in fact, you can even use triple semicolons if you want to have a multi-line text. I will show you an example later on. But if you use any of these, you create a string and you can store it in a variable. And so a string is just another, a string in Python is basically a list of characters. So one thing that you can do is you can this slice notation that we also used for lists to get a substring. So if you use s square bracket 8 to 17, close square bracket, you will get a substring from character 8 to character 17. You can, the same way, you can check if a certain character is in a list. So you can ask, is colon in S? And you can use this, for example, in an if statement to check, to perform an operation if it is. You can use the find method to check if a character, or in fact a substring, is in a list. The split method that you can apply to strings is really useful. It splits the string at a given character. So for example, if you have a string that you read in from a file and you want to split it on all the new lines, then you can use s.split \n. And that will return a list, and each item in the list corresponds to one line in this file. And the same way, you can split using comma or semicolon and so on. If you don't pass any arguments to split, it will just split the string based on white spaces. You can use the replace statement to replace certain values in the string. You can lower all the letters in the string or upper them. You can use the strip function to remove leading and trailing white spaces. So that's often quite useful if you read in something from a user. You want to unify that string, and in particular, the first thing you want to do is remove any kind of white spaces that the user might have typed in before and after the string. Another very useful operation that I often end up using is that I have a list of words in the program, and I want to print it out in a nice way. And so a nice way of printing out a list of words is by separating them by comma. And you can use the join method on that. So what you do is you first make a string with a separator. So in this case, maybe comma space. And then you call the join method, and you provide the list of words that you want to have joined. And the output will be the first item on the list. The output will be a string with all the items in the list separated by comma space. So that's quite useful for very easily printing out lists in a nice way. So as I mentioned, strings in Python can be created either by using single quotes or double quotes. Or if you have a multi-line text, you can use these triple quotes, and then everything will be a string up to the point where you use triple quotes again. So this works in basically all cases except if you want to have backslashes in your string. If you want to have a backslash in your string, you need to specify it as a double backslash. So basically here I want to have a string that has a few backslashes, but for every backslash, I actually type in 2 backslashes. And then I will get the effect that I want. The alternative is to tell Python that I really want to have each backslash a backslash. And I can do this by adding this R specifier in front of the string notation. And if Python sees that, then it will interpret each backslash really as a backslash. So if you add this R, then you don't need to do these double backslashes. Okay, let's talk about control structures in Python. So with control structures, I mean if statements, for loops, when loops, and so on. So we have 2 basic types of loops in Python. The first one is a while loop, and the syntax is written down up here. So you start the while loop with the keyword while, then you add a condition here. So this needs to be a Boolean. This is an expression that needs to evaluate to a Boolean value. So this could be while I is smaller than 10, or while not found, where found is a Boolean expression, or maybe I equals j, something like this. And then after that, you have a colon to indicate that the condition is finished. And the next lines after that will be part of the while loop. And so there's something important to note here, is that in Python, you don't use curly brackets to specify the end and the beginning and the end of the while loop, like you do in C, for example. Instead, you need to indent the code that is part of the while loop. So typically, one uses 4 spaces for every line that is part of the while loop. Okay, and if you don't do this, then the Python interpreter will complain. The Python interpreter will also complain, for example, if you use 4 lines in the first line and then 3 lines in the next line, because it wants you to write everything in a clean way. And so part of the reason why this is done is because of readability. You as the programmer are forced to write the program in a specific format, and that makes it easier for other people to read the program, and it also makes it easier to write the program in a structured, nice way. So this while loop here this block of statements here will be executed as long as the condition is true. Then we also have a for loop in Python. So for loops are used to loop over lists, over items of lists. So the for loop reads as follows. You use the for keyword at the beginning. Then you specify how each element should be called. So this is an arbitrary name that you can type in here. And this will be an updated value for each loop that you're performing. And then you use the in keyword, and then you provide a list. So you must have defined a sum list before that program, and then you can loop over each element in that list. And then Python will execute these block of statements with an updated element variable for each element in your list. And so as I mentioned, this sum list argument here must be an indexable object. So for example, you can use a list, you can for loops over lists or tuples or strings, because they're all objects where you can use the index notation. And as I mentioned, something really important to note is that both for for loops and while loops, you need to use indentation to determine the start and the end of the blocks. So there are no brackets in Python. And so the default is to use 4 spaces. Then we have if statements, of course. If statements work very similarly. So we have if, then a condition, colon again to indicate that the condition is finished, and then the block of statements. We can also have an else if, which is in Python just elif. then with another condition, which is being called if the first condition wasn't true. Again, with a bunch of statements. And then we can have an else statement that is called if none of the conditions before was true, again with a bunch of statements. Again, all the conditions need to be Boolean expressions, and you need to use indentation to separate the end, to indicate the start and end block of each section in the conditional. So often what you want to do is you want to loop over a range of integers from 1 to 10 or from 0 to 5. And the reason why we often want to do that is because integers are often, or integer sequences are often used as indices in lists, for example. And Python comes with a built-in command called range that allows us to exactly do that. So a range allows us to iterate over a sequence of numbers. So for example here, I can type in for I in range 3 and then print the value I. And what that will give me, it will run, this will result in 3 for loops. So I will see 3 print statements. In the first loop, I will be 0. In the second loop, I will be 1. And in the third loop, I will be 3. So just a remark for everyone who's used with to Python 2. So in Python, range in Python 3 is equivalent to X range in Python 2. So if you remember, X range was it created an iterator over integers, while the range in Python returned a list of integers. So in other words, if you just do print range, we can do this here, print range of 10, in Python 2, this would have resulted in a list of integers ranging from 0 to 9, while in Python 3, you only get this range iterator. So this is just a technical difference between the two. But these loops here, so the reason why this has changed is because it's more efficient. In Python 2, if you typed in range 10,000, then you would allocate 10,000 numbers. While in Python 3, you don't actually allocate it. You don't need to allocate it to loop over all these numbers. So it's just a technical difference for everyone who's used to Python 2. But I suggest that we take a break and start again at 1:15.